Okay, let's unpack this.
Let's do it.
We've hit this moment in AI where the big questions aren't just technical anymore.
No, not at all. They're fundamentally philosophical, and we're seeing two of the heaviest hitters in the entire field just colliding head-on.
Absolutely. For this deep dive, we are looking at a high-stakes confrontation between two titans.
That's the only word for them. You've got Yann LeCun, Turing Award winner, chief AI scientist at Meta.
And on the other side, Sir Demis, Nobel Prize winner, CEO of Google DeepMind.
I mean, this is AI royalty.
Hmm.
And they could not disagree more on what intelligence even is.
And this is so much more than just, an academic squabble. This is a proxy war for the future architecture of, everything being built.
It really is. Hassabis is flying the flag for the big universal foundation model, the path we call general intelligence.
And LeCun is the revolutionary, saying that whole path is basically a dead end.
And he's not subtle about it. The core conflict here is just so provocative. LeCun flat out declared there is no such thing as general intelligence. He called it a myth.
And Hassabis' response was just as blunt.
Oh, yeah. He fired back, calling LeCun's view plain incorrect.
That sets the stage perfectly. So our mission today is to get past those sound bites. We're going to dig into the theoretical scaffolding, the math and biology behind their ideas.
And this is the critical part, we're looking at the hard evidence from 2025.
We're talking about Meta's V-JEPA 2 and DeepMind's Gemini 2.5 and Sima 2. We want to see which approach the actual tech, the breakthroughs, are proving right.
We're going from the philosophical debate right into the lab results.
Okay, let's start with the theory. This entire fight really comes down to two completely different ideas of what smart actually means. So what's the heart of LeCun's position, this idea of biological constructivism?
Right. For LeCun, true generality is basically an illusion. He argues that the human mind, the thing we hold up as the gold standard, it's not general at all.
Not general.
No, he'd say it's super specialized. It's a collection of incredibly efficient tricks or heuristics that evolution carved out for one very specific purpose.
Surviving on planet Earth.
Exactly. We're smart, but we're only really smart at being human here.
And there's a mathematical anchor for that skepticism, right?
There is. It's a really deep concept in math called the no free lunch theorem.
Okay.
The core idea is that if you design an algorithm to be amazing at one set of problems, it must pay a penalty somewhere else. You can't be optimally efficient across every possible problem in the universe.
So trying to build something that's perfect everywhere it's a doomed mission from the start.
It's fundamentally dinged.
Yeah.
LeCun looks at that and says, see, the moment you optimize for the real world for things like gravity, causality, moving through space, you are specializing. You have to. You can't get that efficiency without giving up on that dream of universality.
Okay, so if LeCun says we have to specialize to be efficient, what is Hassabis' counter? What's this computational universalism?
Hassabis' LeCun is kind of missing the point of the goal. His focus is on a different mathematical definition of intelligence. It's one that defines intelligence as the ability to get rewards across all relevant and computable environments. So it's not about solving every chaotic problem possible.
It's about solving problems in structured realities, like ours.
Exactly. And he anchors this in a powerful metaphor, the Turing machine.
The universal computer.
Right. He basically says the human brain and these big foundation models, they're like approximate Turing machines. They're not specialized hardware like a calculator. They are general-purpose processors.
Oh.
And you can load any software onto them.
Like learning to write a symphony
Or mastering chess, a game that didn't even exist when our brains were evolving.
I remember LeCun pushing back hard on that analogy, though.
He did, and it's a fair point. LeCun argues that, the real-world biological constraints, our energy limits, how fast our neurons can fire, the architecture baked into our genes, it makes the brain so different from some theoretical infinite Turing machine that the metaphor just isn't useful for actually building things.
So we've got this standoff. LeCun's necessary specialization versus Hassabis' fundamental universality. Is there any middle ground? A place they both agree?
Yes, and this is so important. The computer scientist Francois Chollet put it perfectly. He said, true intelligence isn't the skill you already have.
It's the efficiency of skill acquisition.
Exactly. It's how fast you learn, not what you know.
And they both see that.
They do. Hassabis says AGI has to be capable of learning anything, and LeCun is the first to say that Today's LLMs are horribly inefficient. They need trillions of words to learn what a toddler picks up just by, bumping into things.
So that forces the debate away from philosophy and right into architecture.
Here's where it gets really interesting.
Because LeCun isn't just theorizing. He has launched this massive, direct attack on the main AI architecture we use today, the autoregressive large language model.
The LLM, yep.
Why does he call it a rampway to nowhere?
It boils down to one deep, inescapable flaw in how they work. He calls it the drift of hallucination.
Okay, break that down.
Think of it like a game of telephone. When an LLM generates its first word, or token, it might be 99% sure it's the right one, but there's always that tiny chance of an error.
And since every single word it says next is based on the words that came before.
Including any mistakes. The whole thing just collapses. The
Wow.
integrity decays exponentially.
Well,
The longer it talks, the more likely it is to drift off into just making things up. For short answers, it's okay. But for complex reasoning, it's a time bomb.
that makes so much sense. It's just compounding its own errors over and over with no external check.
And that leads right into his second big criticism, the ontological gap.
Meaning?
He argues that text is just. It's low bandwidth. Relying only on text to learn about the world is like reading 1,000 books about swimming.
You know all the theory, but you've never actually touched water.
You've never felt buoyancy. You haven't experienced resistance. It's a completely ungrounded kind of intelligence. He believes to really reason, to act in the world, you need that high bandwidth input from vision, from interaction. You had to see causality.
Yes. So if the current method is a rampway to nowhere, what's LeCun's fix? What's his architecture?
It's called JEPA, the Joint Embedding Predictive Architecture. The core idea is all about efficiency.
How so?
Okay, so traditional generative models, they waste so much energy. If you show them the video of a car, they try to predict every single pixel. They try to predict the random movement of leaves on a tree in the background or the exact reflection in the windshield.
The nuisance variables, right? The stuff that doesn't actually matter for understanding what's happening.
Exactly. JEPA throws all that away. It doesn't predict pixels. It predicts abstract representations in a much more efficient, sort of compressed space.
Yeah.
It just learns the important stuff: position, velocity, trajectory.
It learns the underlying physics, not the surface level details. And what's the payoff for doing that?
The payoff is that you can do real planning, what's called model predictive control. Because the AI has this stable internal world model, it can simulate thousands of possible futures in its own mind, or its latent space, in a fraction of a second.
So it can think, if I do this, that will happen before it ever acts in the real world. True System 2 thinking.
That's the goal. And the sources show this wasn't just a theory. They proved it in 2025 with V-JEPA 2.
Right. Tell us about the aha moment from that research.
Okay, so V-JEPA 2 was trained on tons of unlabeled video. Its only job was to predict what was going to happen next in that abstract latent space. The real test came when they hooked it up to a robot arm for a simple pick-and-place task.
Something it had never been trained for specifically.
Exactly, zero shot. V-JEPA 2 was able to plan the entire sequence of motions in just 16 seconds.
Wow, 16 seconds for a brand new task is incredibly fast.
It's astounding. But here's the kicker. They compared it to a state-of-the-art generative video model doing the exact same task.
And how long did that one take?
4 full minutes.
Whoa, that's a 15x speed advantage.
It's not just a small win. This is the physical proof of LeCun's no free lunch argument.
Yeah.
That specialized efficiency, in this case for modeling physics, is absolutely essential if you want to act in the real world.
That is powerful evidence. It really makes it seem like the universalists are on the wrong track. But Hassabis and DeepMind, they weren't standing still. They saw these critiques.
They were evolving.
Let's look at their defense. Why did they stick with the massive transformer, the universal learner, even with these clear problems?
Hassabis is just convinced that scale and multimodality can solve it. His argument is that if you make the model big enough and you train it on everything, text, images, code, action, sound, it just learns a single unified representation of the world that is general. The architecture itself becomes the general learning algorithm.
And he uses that chess counterpoint to poke holes in LeCun's idea of human specialization, right?
He does. The argument is, if we were only specialized for the savannah, how on earth did we invent and then master chess? It's a completely abstract, novel game with zero evolutionary history. An ant can't learn chess. A human can. That ability to learn new complex things, even if we're not born to do them, that, for Hassabis, is the proof of generality.
But DeepMind still had to solve LeCun's biggest criticism, that drift of hallucination. They had to make it more reliable. And that's where Gemini 2.5 and its thinking models come in.
This is where it all starts to come together. DeepMind basically admitted that the pure System 1 next token prediction wasn't enough for hard reasoning. So they added a hidden internal thought process.
An internal thought process? How does that actually work?
It's like a little text-based world model inside the bigger model. Before Gemini 2.5 gives you a final answer, it internally brainstorms. It writes out different lines of reasoning. It checks them for errors against its own knowledge. It refines its ideas.
It does all of that before generating the output we see.
Right. It's simulating a rigorous System 2 deliberation process inside the massive System 1 architecture.
So they basically took LeCun's idea that you need internal simulation and planning and bolted it onto their universal model.
You could absolutely see it that way. And the performance shot up. This new mechanism let Gemini 2.5 crush it on totally different tasks at the same time, like high-level coding and really hard math competitions. It was showing cognitive generalization because it had that internal fact checker.
Okay, so if Gemini shows cognitive generalization, then Sima 2 was the test for embodied or physical generalization. This seems like a direct response to LeCun's ontological gap idea.
Sima 2 is probably the strongest piece of evidence for the universal agent camp. It stands for Scalable, Instructable, Multi-World Agent. They trained it across dozens of different 3D video games.
But the real test, the only one that matters for generalization, was putting it in unseen worlds.
That's the whole ballgame. This wasn't just a new level of a game it knew. They dropped Sima 2 into games with totally different physics, different art styles, different rules. Games like Mina Dojo or Askai that it had never, ever seen.
And then the question was, could it figure out what to do? Could it generalize the idea of being an agent in a world?
And it could. Sima 2 showed robust, immediate generalization. You could give it a high-level command like, find wood and build a shelter. And it would identify what resources were, what tools were, and how to use them in a brand new environment.
It proved that a single big architecture could learn a general concept of agency that transfers.
It really did.
So this data from 2025 is just fascinating. You have V-JEPA 2 on one hand, proving specialization is key for fast physical action.
And then you have Gemini and Sima 2 proving these universal architectures can learn and operate in totally new domains.
It really feels like the debate isn't about who's right or wrong anymore. It's about what the division of labor looks like in the final AGI system.
I think that's exactly where we've landed.
Okay, so what does this all mean? Let's synthesize this and render a verdict on their core claims. First, on the noun. Is general intelligence a real thing?
The evidence here points pretty clearly to Hassabis being correct. The concept is valid because the ability of something like Sima 2 to master a game it's never seen, or for a foundation model to learn a totally novel field like quantum computing, that capacity is fundamentally different from a specialized system like Deep Blue, the chess computer, or an insect. That ability to learn abstract new things is not an illusion.
Okay, now for the verdict on the verb. How do we actually build it?
On this, LeCun is completely vindicated. His architectural critiques have been proven right.
His argument that just scaling up the old models isn't enough.
Exactly. The fact that DeepMind had to add that explicit System 2 thinking model to make Gemini work properly proves that you need that internal world model. You need that rigorous planning and grounding that LeCun was demanding all along.
So the future architecture isn't one or the other, it's a hybrid.
It's a hybrid. We can call it grounded generalism.
Explain that.
You use the big foundation model, the Hassabis-style universal learner, for its incredible breadth of knowledge and its ability to learn anything. But you couple that with an efficient LeCun-style world model that grounds it in physics and logic and lets it plan and simulate before it acts.
And you, the listener, should know this isn't just an abstract debate. This is dictating the shape of the tools we're all going to be using very soon, especially as AI moves out of our text boxes and into the physical world of robotics and science.
And you know, there's a final deep paradox in all this that the source material points to. Gemini 2.5 got its general reasoning powers by essentially taking a LeCun-style world model, that internal thought process, and embedding it inside Hassabis' universal agent.
Which leaves you with a final provocative thought to chew on. If the universal agent needs to rely on a highly specialized, grounded simulation of reality to achieve its robust reasoning, does that mean LeCun was right all along? Is all effective intelligence at its core just hyper-specialized for the single critical task of modeling a consistent reality?